Hey Algebra students, we have a lesson today over proportions and similar figures. So it's basically what we did yesterday, but you're going to see more real life applications today. So let's go ahead and find example number 1. And this introduces a little bit of geometry. So we're asked to determine if the pairs of triangles are similar, and they're only going to be similar if they have the same exact proportion for each of the sides. So what we need to do is we need to set up our ratios for corresponding sides. And when I give you a list of numbers like this, your corresponding sides are going to be your first numbers together. So we can make a ratio of 8 to 12. And then if we look at that, that can be reduced by 4 to 2 over 3. Okay, so then we want to do the same thing with my middle sides of 10 and 15. Again, make a ratio of that of 10 over 15, because whatever I put on top in my first fraction, I need to make sure I put on top in my second fraction as well. So I can reduce these both by 5, again, to get 2 out of 3. So far, it's looking like we have similar figures, but we always have to check the last one. So you've got your 16 from your first triangle and your 24 from your second. Both of those can be reduced by 8, again, giving you a 2 over 3. And because of all of these, because these are all the same, these are similar. Okay, so if we do the same thing with question number 2, take your first side, so 2 and 4 from each triangle, so put 2 over 4, reduce that to 1/2. Okay, so that's what we're going to look at to see if we can match. So if I put 2.5 over 5, that's also going to reduce to 1/2 because 2.5 is half of 5. And then we have our last sides of 3 over 6. Again, reduce that. That becomes 1 over 2. So because 1/2 equals 1/2 equals 1/2, these triangles are, again, similar. All right, so we can also use proportions to figure out missing sides of triangles. So in these bottom two examples, well, example 3 and 4, I give you triangle PQR and triangle STU. So you guys can see on my slide, I have two different size triangles. So this bottom one, or I'm sorry, this top one is going to be triangle PQR. Okay, that way I can label my sides. And when we label my sides, wherever I start in the first triangle is the same side I have to start in my second triangle. So if I started on my left side with my first letter, on my second triangle, I have to start on the left side with my first letter and follow the same pattern. All right, so now what we want to do is we want to take the information that we know over here. So I know side R is 15. I know side S is going to be 8. T is 6, and U is 10. Okay, so the next thing that we want to do is we want to find two corresponding sides that have numbers, meaning we can make a ratio out of them, and those sides for us are going to be side R and side U, because I know it's 15 and 10. So I'm just going to take 15 and put it over 10. So in order to find a missing side, I have to set up another ratio. So with that, we need to figure out if I want to find side P or side Q first. And honestly, it doesn't matter. Let's just find side P first. So because I don't know side P, that's going to go in the top of my next ratio because the top numbers have to come from the same triangle. Okay, so 15 and P are in the same triangle. Now, my corresponding length for P is side S, and side S has a unit of 8. Okay, and then this is what we did yesterday. You have to cross multiply to solve this. So you have to do 15 times 8 and 10 times P. So the equation that you're going to get is 10P is equal to 120. And then we're just going to divide each side by 10. And we find that in this case, side P has a measure of 12. Okay. So that's it for finding side P, but we also need to find side Q. So if I want to find side Q, we're going to use our same first ratio. We're going to use that 15 over 10 because I know that that's going to be exact, and I didn't calculate it, so I know that I didn't go wrong finding it. We have to set that equal to my ratio with side Q. So side Q comes from my top triangle, so that has to go on the top. And then what side corresponds to Q on the bottom one? It's T, and T is equal to 6, so that's my new denominator. Then just like we've been doing, cross multiply. So again, 10Q this time is going to equal 90. Divide both sides by 10, and we find that side Q has a measure of 9. Okay, and you're done with that problem. So let's do number 4 in a very similar way. So we're dealing with the same triangles, but we're going to have different side measures, and we might need different or a different ratio. So fill in my missing stuff here. Okay, so side R equals 20. Now we know P right off the bat. We also know Q right off the bat, and we still know U right off the bat. So now what we want to do, just like last time, is we want to figure out what two sides are corresponding that we know both measures of. Hopefully you guys can see that those two sides are going to be R and U again. So we can put our top triangle on top, so 20 over my bottom triangle. And then we're going to use that ratio to set up another one that corresponds to sides we want to find. So let's find side S first. It just comes first in alphabetical order. So because I want to find side S, I need to put that one on the bottom because that one came from my bottom triangle. So now what side corresponds to S? Hopefully you guys see that it's P, and P has a measure of 12. So then from here, all we're going to do is cross multiply. Okay, so 20 times S is going to give me 20S. And then when I do 15 times 12, we get 180. And then this is just your one-step equation of dividing by 20. And we find that S has a side length of 9. And we're halfway done with the problem. Okay, the other half of the problem is to start with our first ratio again of 20 over 15. But now this has to be equal to the other side that we want to find. And the other side that we want to find is T. So T came from my bottom triangle, so that has to go on the bottom. And then my corresponding side to T is Q, and Q has a measure of 8, so that goes in the top. So let's use our cross products. Go ahead and cross multiply 20 and T to get 20T is equal to 15 times 8 is 120. And then divide both sides by 20. And then we find that T has a side length of 6. That's it. We're done. Okay. Now, number 5, we're getting a little bit out of geometry now, and we're dealing with some architecture. We're going to go to blueprints. So in a particular blueprint for a house, it states that 2.5 inches on the drawing is equal to 10 feet in real life. And then if we have a length of the wall that's 12 feet in real life, we want to figure out how long to make it on the blueprint. So we want to set up our first ratio. So notice that in this problem, we're given a ratio right here. We're given 2.5 inches equals 10 feet. So that's going to be our first ratio. So 2.5 over 10 feet. So this tells us that when we set up our other ratio, inches has to go on the top and feet has to go on the bottom. So let's gather our information. So I have the length of the wall that's 12 feet. So because that's feet, it has to go in the denominator. And then it asks us how long is the wall in the blueprint. Well, I don't know that. How long always means to put in an X. So X has to go on the top. And then you're just cross multiplying to solve. So 10 times X gives me 10X. 2.5 times 12 gives me 30. So 10X is equal to 30. Divide both sides by 10. Now X is equal to 3, and you're 90% of the way there, except I need to see 3 inches just to make sure we know we are all talking about the same thing, okay? All right, so number 6, very similar, okay? So we can use scales when we're talking about road maps as well. So on this scale map for Connecticut, any 5 inches on the map is the same as 41 miles in real life. And then we have another map of Texas where 5 inches there is going to equal 144 miles, just because Connecticut is really small and Texas is really big. So obviously 5 inches on the map of Texas is going to be more in real life. What we want to do is we want to figure out the distances in miles represented by 2.5 inches on each map. So we're going to set up our ratio or our proportion for Connecticut and solve that one first. So we're going to take our first ratio of 5 inches equals 41 miles, and we're going to put that into smaller over the bigger. And it doesn't matter, you could put 41 over 5 and that still works. And then we're asked to find what 2.5 inches on the map represents in real life. So that 2.5 or 2.5 inches has to go on the top, and we don't know how many miles that is, so we're going to put that on the bottom. So notice how my inches are in my numerators and my miles are in my denominators. That has to check out every time. So now cross multiply. So you've got 5x is equal to 41 times 2.5, or 102.5. Divide both sides by 5. And we find that in real life, 2.5 inches on the map of Connecticut is the same as 20.5 miles. Right? So there's one of our answers. Now the second answer we need to come up with is for Texas. And we don't want to use this 5 over 41 because Texas's scale is different than Connecticut's. That 5 is still going to go on the top. We've still measured 5 inches, but that represents now 144 miles in real life. This 2.5 inches over x is going to stay the same because I've measured that, or that's what I'm trying to find. So go ahead and cross multiply. Again, you're going to be left with 5x, but this time you're going to be equal to 360 because when you multiply 144 times 2.5, that's what you get. And then divide both sides by 5. And we find that in real life, 2.5 inches on the map represents 72 miles. Okay, so that's where we can use blueprints to help us with scale models and scale drawings. All right, we have 2 more. Okay, so this one, again, we're dealing with a map of a world. And this on this world map now, 2 inches is going to represent 250 miles. Okay, so there's our initial ratio. So 2 inches over 250 miles. And then we want to figure out how many miles it is between Moscow and Paris if that distance on the map, okay, so that distance on the map is 15 inches. So we're dealing with inches. Inches has to go on the top. I don't know how many miles it is because that's what it asks us. So that has to be x. All right, guys, go ahead and cross multiply. So we've got 2x is equal to 250 times 15 is 3,750. Divide both sides by 2, solve that one-step equation, and we find that x has a value of 1,875 miles in real life between Paris and Moscow. All right, last one. Almost there. Promise. Okay, so this time we can use our similar figures and proportions to use shadows to figure out if somebody or how tall somebody is. So we have a man who is 6 feet tall. So this little dude in our picture is 6 feet, standing next to a flagpole. And then the shadow of the man, so we know shadows extend out from his feet, right? Here's his shadow. That shadow is going to be 3.5 feet. Right? And the shadow of the flagpole then, so I know this should go in the same direction, but it's going to get confusing. So there's the shadow of the flagpole. That has a length of 17 feet. We want to figure out what the height of the flagpole is. So we don't know how tall that is. So this one, we have the same unit of measurement. So what we have to do is almost put vertical over horizontal. So we're going to put our vertical height over our horizontal distance. Okay, because both the person and the flagpole go up, and those are the same thing. And then our horizontal distance, our shadows, both go out. So that's probably the easiest way to come up with your proportions. So the height of the man is 6 feet. That has to be equal to my flagpole ratio. Well, the height of the flagpole, I don't know, so that's going to go over X feet. Okay, so then we have to deal with, so this is the man, this is the flagpole. So now we have to put your ratio for your shadows on the bottom. So that's our horizontal distance. So 3.5 feet gets put over my flagpole distance of 17.5 feet. So in this one, it was important that not only did we put the same piece of our puzzle on top, but we also made our ratios come from the same person or the same object. And then once we have that set up, cross multiply. All right, so we've got 3.5x is equal to, 17.5 times 6 is 105. And then we're going to divide that by 3.5. And we find that x has a value of 30. And then since everything is labeled in feet, that's going to be 30 feet. So that tells us that this flagpole is 30 feet tall. Okay? And this is actually a method that you can use to accurately find the heights of objects. So bring any questions you have the next time we see each other, and we'll get everything squared away then. Bye, guys.